like, share, and subscribe to Sir Gibbs TV.
Hi guys, we're back again for a brain exercising learning. But before we start our discussion, I want you to prepare a pen, a notebook, your printed module, and a calculator.
So our most essential learning competencies are: first, illustrates permutation of objects. Second, solves problems involving permutations. Let's have a game first. I want you to multiply 20 by 19, then by 18, then by 17, up to by 1. Can you get the correct answer in just 3 seconds? You're right. It's a no. But with the use of a calculator, you can do it in just 3 seconds. But how? Try to get your calculator. You just press 20, the shift button, then the exclamatory mark in your calculator. Press equals, then it's now a magic. In math, the exclamation point is called factorial. Factorial is the product of all positive integers less than or equal to a given positive integer and denoted by that integer n and an exclamation point. Thus, this is read as n factorial. In the previous example, our n is 20. So to get the product, let us represent it by 20 factorial. 20 factorial means 20 times 19 times 18 times 17 times 16 times 15 2 times 1. And that is equal to 720. Now, can you evaluate 3 factorial in 3 seconds? What's the answer? That's right, 6. 3 factorial means 3 times 2 times 1, and that is equal to 6. Now, evaluate 2 factorial plus 4 factorial. Can you answer this in 10 seconds? That's great. Your 10 seconds starts now. Time's up. What's your answer? That's right, 26. For the solution, 26. That's great. I think you're now ready for an activity. For your activity, you're going to evaluate the following. Answer this within 2 minutes and submit your answer in the Google Classroom. A few moments later. You are now done answering your activity. Now, let us connect the previous activity to our lesson through this situation. 5 frontliners were on a break. They were hungry and wanted to buy something to eat. Suppose that each of them can choose a sandwich and a drink. List all the possible outcomes from the choices. The choices are: for sandwiches, for beverages. So what are the possible outcomes? The possible outcomes are hamburger and orange juice, hamburger and coffee, chicken sandwich and orange juice, chicken sandwich and coffee, egg sandwich and orange juice, egg sandwich and coffee. So there are 6 possible outcomes from the choices. Next activity, I want you to rearrange all the letters of the word era. List all the arrangements. How many arrangements do we have? Can you guess the number of arrangements? Is it 4? Is it 5? Is it 6? That's right. There are 6 number of arrangements of the word era. So here are the 6 arrangements. Now, can you give me one word that can describe our lesson? That's right, an arrangement. As you have seen, an arrangement can be applied to words and can also be used in many other situations. In mathematics, arrangements corresponds to the word permutation. It's now obvious that our topic is all about permutation. A permutation of the set of objects is an ordered arrangement of the items. In English, one good example of permutation is an anagram. An anagram is a type of wordplay wherein the results of arranging the letters of word or phrase produce a new word or phrase by using the original letters exactly once. For example, the word silent is an anagram of the word listen. If we try to go back to the arrangements of the word era, there we have 6 arrangements. These are Now, if we will use the factorial notation, the n factorial, that is 3 factorial, since there are 3 letters of the word era without repetition. For the solution, we have 3 factorial is equal to 3 times 2 times 1 is equal to 6. Another example. In how many ways can the letters of the word COVID be arranged if all letters are used? Any guess? That's great. The answer is 120 arrangements. For the solution, since COVID has 5 letters without repetition, then we will use the factorial notation where n is equal to 5. Therefore, the solution will be n factorial is equal to 5 times 4 times 3 times 2 times 1. That is equal to 120 arrangements. N factorial can only be used for arrangements without repetition. Let's consider this another example. In how many ways can 7 different potted plants be arranged in a row? If you can read the word different, it is considered as without repetition. Therefore, to find the possible arrangements, the factorial notation n factorial can be used. Since there are 7 different potted plants, therefore, we have 7 factorial is equal to 7 times 6 times 5 times 4 times 3 times 2 times 1. And the possible arrangements would be 5040 ways. Now, let's try to look at this example. How many different ways can the 6 Grab food motorcycles be parked if there are 8 available parking spaces? Can we apply the factorial notation? Is it yes? Right? It's a no. In permutation, there are lots of formula to consider. But in our video lesson, we will only consider the 2 formulas: the factorial notation and the permutation of n objects taken R at a time. For permutation of n objects taken R at a time, the formula is NPR is equal to n factorial over n minus r factorial, where n and r are positive integers and r is greater than or equal to 1 and less than or equal to n. NPR is read as permutation of n objects taken R at a time. Now, let's go back to our previous example. How many different ways can the 6 Grab food motorcycles be parked if there are 8 available parking spaces? We will now use the permutation of n objects taken R at a time. Let us denote the available parking spaces as our n and the 6 Grab food motorcycles as our r, since n must be greater than or equal to r. For the solution, we will now use the formula permutation of n objects taken R at a time is equal to n factorial over n minus r factorial, where our n is equal to 8 and r is equal to 6. So we'll have permutation of 8 taken 6 at a time is equal to 8 factorial over n minus 6 factorial. Simplifying, we have 8 factorial over 8 minus 6 factorial is equal to 2 factorial. Then 8 factorial is equal to 8 times 7 times 6 times 5 times 4 times 3 times 2 factorial over 2 factorial. Cancel out 2 factorial, then simplify. 8 times 7 times 6 times 5 times 4 times 3. Using your calculator, the result would be 15,120 ways. Another example. A teacher wants to assign 4 different tasks to her 6 students. In how many possible ways can she do it? To determine the number of ways, we will use the formula NPR is equal to n factorial over n minus r factorial. Then, let us substitute 6 to n and 4 to r. So that will be permutation of 6 taken 4 at a time is equal to 6 factorial over 6 minus 4 factorial. Simplify, it will become 6 factorial over 2 factorial. Simplify again, we'll have 6 factorial is equal to 6 times 5 times 4 times 3 times 2 factorial over 2 factorial. Then cancel out 2 factorial, the result would be 6 times 5 times 4 times 3, and it is equal to 360 ways. To master the topic, I want you to answer the activity and attach your answer in our Google Classroom. You may answer the activity within 5 minutes. A few moments later. Great job! You've done the activity right. Answers were shown in the Google Classroom. To evaluate yourselves and to check if you really mastered the topic, answer the evaluation. Show your solutions and attach your answer in the Google Classroom. A few moments later. Congratulations, and that's it for our video lesson. If you have any questions or clarifications, you can message me in our Google Classroom, or you can play the video again for mastery. You can also practice answering some questions or problems regarding permutation in your module. For your assignment, it's been attached to your Google Classroom. Study in advance about combination and write the formulas related to it. Once again, this is Mr. Gilbert M. Acompañado saying goodbye, and let's stay all negative.